friends, how are you? I hope you all are well. In my last video, I explained about electric charges, which is one of the best or starting concept of electric charges and field. Today in this video, I am going to explain about electrification. So what do you mean by electrification? The process of charging an uncharged body. The process of charging an uncharged body is called electrification. That means in this video I shall explain how to charge an uncharged body. But this electrification can be achieved by mainly three different ways. One is friction, second one is the induction, third one is the conduction. That means we can charge a body by three different ways, either by friction or by induction or by conduction. So at first I shall explain about the electrification by friction, or we can say frictional electricity. Electrification by friction, or we can say frictional electricity, or I can say I am going to explain electronic theory of frictional electricity. Electronic theory of frictional electricity. I am explaining how we charge a body by friction. Frictional electricity or electrification by friction. You know that all matter made up of several atoms. In each atom there will be a nucleus. In each nucleus you will find protons and neutrons. As a result, the nucleus is positive in charge. At the same time, the nucleus is surrounded by number of electrons in its different cells. Last class we discussed, we accepted electron as negative charge and proton as positive charge. So in each matter you will find large number of atoms are there. In that atoms nucleus there. Nucleus is positive charge due to protons and neutrons. At the same time number of electrons we find in different cells. So in a matter, if you take as a buck, each matter is electrically neutral. Neutral in the sense the positive charges and the negative charges, they cancel each other. So I can say that matter is electrically neutral. Matter is electrically neutral because here the positive charges and negative charges, they cancel each other. As a buck, matter is electrically neutral. Now I want to explain the frictional electricity. Now let us see, suppose we will take one glass rod and silk cloth. Many times you might have been studying these things in your high school level. Whenever we rub a glass rod with a silk cloth, what happens? There is a transfer of electrons from glass rod to silk cloth. Why electron transfer from glass rod to silk cloth? The fact is that when the electrons are present in its cells, we need some energy to remove an electron. That is called work function. The amount of energy required to remove an electron, the amount of energy required to remove an electron. The amount of energy required to remove an electron from its outer cell is called work function. From its cell, or you can say outer cell, is called work function. Between glass, why I am saying about the work function? I said that transfer of electron takes place from the glass rod to the silk cloth. What the reason? The reason is that work function of a glass rod is lower than work function of a silk cloth. So I can say that work function of glass rod less than work function of silk cloth. That means how much amount to energy I need to remove an electron from the glass rod is less than the amount of energy required to remove an electron from the surface of the silky cloth. So the work function of a glass rod is lower than work function of a silk cloth. That's why the electron transfer from the surface of a glass rod to the surface of a silk cloth. As a result, glass rod becomes positive charge, silk cloth becomes negative charge. But the total charge present in glass rod and silk cloth is 0. That's why, because my previous video I explained energy is conserved. How much charge was there? Same charge is there. There is a transfer of charge, no doubt at all. But the total charge remain constant. How much positive charge? That much negative charge. That's why they cancel each other. So I said that matter is electrically neutral. So this is about electrification by friction or frictional electricity. Next point I am going to explain electrification by induction. Electrification by induction, or I can say that electrostatic induction. Electrification by induction, or I can say that electrostatic induction. What is this electrostatic induction? I am giving an example. See here. Suppose this is a conductor. This is a conductor or conducting body. Suppose this is a stand. This is a insulating body. This is a conducting body. Conducting body means, you know, a conductor which can allow the current to pass through it easily. That means which contains sufficient number of free electrons. That conductor or conducting body I have taken. This stand is an insulating body. Okay, that means the current cannot transfer here. For that purposes we have taken insulating body. Now, suppose I shall take a glass rod after rubbing it with the silk cloth. So after rubbing it with the silk cloth, we accepted glass rod as the positive charge. If I bring it near it, what happens? Those free electrons are present. These free electrons will be attracted towards the end A. At the same time, that means number of electrons at the end will increase. There will be excess electrons at the end A. So this end will be negative. At the same time, the remote end or the opposite end, further end, ultimately this end B becomes positive. The fact is that number of free electrons are there. These free electrons are attracted towards the positive end of the glass rod. That's why at the end A there will be excess of electrons. This end will be excess of electrons. At the same time, here there will be deficit of electrons. So deficit of electrons means positive. Excess of electrons means that is negative. But at the same time, when some electrons come here, when further electrons try to come here, they oppose it. There will be a repulsive force. That means here we are finding two forces. Here is the attractive force. But when some electrons are gathering here, further electrons are transferring. They are opposing because there is a repulsive force between electrons and electrons, because we know that like charges repel each other and unlike charges attract each other. So, one equilibrium stage comes. In which stage there will be equilibrium between these attractive forces between the glass rod and the negative charge particles, and the force of repulsion between the electrons. That means one equilibrium stage comes where further shifting of electrons will not take place. So now this end becomes negative, this end becomes positive. These things done by induction. Here there is no contact. So what do you mean by induction? I can say that it is a redistribution of a charge. It is a redistribution of a charge. When the body is placed near a charged body, so I can say that it is a redistribution of charge in an uncharged body when it is placed near a charged body. So what I have written? I have written that a redistribution of charge in an uncharged body when it is placed near a charged body, this is called the induction, or I can say it is a phenomenon, it is a process of temporary electrification. I can say that it is a process of temporary electrification. Why temporary electrification? Because if I take the positive glass rod away from it, this charges will disappear. Charges will be disappear if I take the glass rod, positive charge glass rod away from it. That's why I said that it is a process of a temporary electrification in which opposite charge appears near the charged body and vice versa. That means here the positive end is there, here the negative will appear. Further end, the positive will appear. So I can say that it is a process of temporary electrification in which opposite charge appear near the charged body. Okay, or you can write that and similar charge appear at the further end or the remote end. Further end. So, the process of redistribution of charge in an uncharged body when it is present near a charged body, that is the induction or electrification by induction. Now, one or two examples I would like to give. First one is the charging of two spheres by induction. Charging of two spheres by induction. Okay, now listen carefully. For example, I am taking two metal spheres. It is attached with a insulating stand. Two metal spheres I have taken. Now, these two metal spheres both are in contact. Now I shall take one positively charged glass rod. What happens? You find that this side will become negative, this side becomes positive. Already I said those free electrons are there. Those electrons are present in the outermost orbit. They are the free electrons. They are attracted by this positive end. As a result, this end, excess of electrons, it becomes negative. Other end, there will be a deficit of electrons, means it becomes positive. It becomes negative charge. it became positive charge. Okay. So I said already there will be an equilibrium between this attractive force and repulsive force between the electrons. So a certain number of electrons will be gathered here at the same. Due to that, it became negative and it becomes positive. Now suppose these two metallic spheres somewhat will take away. We will separate them, but this positive charged glass rod must be there. Then what happened? This side becomes negative, this side becomes positive. Now listen carefully. Here there is a positive charge glass rod. Due to this one, this side remained as a, before that, negative. We separated, not much distance, little distance. Instead of that, it is holding this side negative charge, this side is holding the positive charge. Now suppose I shall take away this glass rod. Then what happens if I take away this glass rod? These things happen. The opposite charges, they will attract each other because this is negative charge, this is positive charge. Now I took it away. So when I took it away, this negative one and positive, they attract each other. They attract each other because one side is the negative, one side is positive. Suppose now I shall separate them somewhat more away, far away. Then what will happen? The negative charges will not be here at this side. They will distribute uniformly throughout this sphere. Here also same thing will happen. Here they will be distributed uniformly throughout this sphere. Now this one is the negative one, this one is the positive one. So in this example, I explain how to charge two spheres by induction. One more example I shall give. Single sphere. Charging of a single sphere, suppose. Sphere by induction. Charging of a sphere by induction. Single sphere. Suppose I am taking one metal sphere. This is a insulating stand. Now I shall take one glass rod which is positive in charge. So what will happen? Okay, previous case I took positive. Now I shall take, suppose this is plastic rod. Plastic rod I take, which is negative in charge. This one is a uncharged body. What will happen? You will find that this side will become positive, this side will become negative, because this is already a negative charged body. There will be a repulsion between the negative charged particles. As the result, electron will move away from it. So this end will be excess of electrons, so it is negative. This end will be deficit of electrons, which is positive. Now this body, suppose this body I shall connect it with a conductor to the earth. That means I shall make it acting. Then what will happen? You will find that electrons will enter into the earth. That means still this is there. This negative body is there. but electron will shift. Then what will happen? So here which one will be left? The positive one left. So this positive one left. That means now it becomes positive. Here electrons are there. This side became positive. Suppose I shall take this plastic rod away from it. What happens? This positive charge will redistribute uniformly. That means the body became positive charge. Once again I am repeating. Here I took one uncharged body and one plastic rod of negative charge. Now electrons move to this side, it becomes negative. At the same time this one became positive. If I connect it with one with the help of a conductor with the earth, means if I make earthing, the electron will shift to the earth. That means now the positive charge left. Now I shall remove this negative charge. This positive charge will redistribute uniformly. That means I made this object as positive charge. Similarly, we can make one metallic sphere also negative charge. How I made positive charge? By taking a negative one, by taking the positive one, I can make it also negative one. So this is about the electrification by induction, which is very important for this topic. The last process I said conduction, more details we will study in the current electricity. Just I shall tell what is that conduction. So conduction. Conduction in the sense, suppose this is a positive charge body, this is a neutral body. If both bodies comes in contact, there will be a transfer of charge from one body to another body. After some times, both bodies will get the positive charge, no doubt at all. But how much the amount of charge, it depends upon the size, shape, other factors. But both will achieve the similar charges, means positive charge. So I can say that conduction means the process of transfer of charge, similar charges, or you can say that it is the accumulation of similar charges by a body. I can say that it is the accumulation of similar charges by a body when it is placed in contact with a charged body. So the process of a transfer of charge, similar charge, one body to another body, when they are in contact, that is called the conduction. More about the conduction we will study in the current electricity. So children, I hope that you will be able to understand the facts what I explained in the video. In the next video, we will see the Coulomb's law. In addition with that, I shall explain about the electric force and the electric field. Until then, bye.